Student, in this lecture, we will discuss about electric field and electric field intensity. Student, please keep in mind that every charged particles have associated electric field of lines. So, electric field of line associated with charged particle uh, or with a charge have electric field around it. Electric field is a region around a charged particle or around a charge in which when another charge is brought closer to it, then it feels a force. This force could be a force of attraction or a force of repulsion. So we can write the definition of electric field as electric field is basically it is a region around a charge in which when another charge is brought closer to it, feel a force of attraction or repulsion. So basically electric field is just an imaginary, it is an imaginary region around a charge. Dear students, since you know that there are two types of charges, one type of charge is a positive charge, whereas another type of charge is a negative charge. Every charge have associated electric field of line with it. So in positive charge, the electric field of line are present around it, and these electric field of lines are directed outward from the positive charge like this. Please keep in mind that the electric field of lines are basically imaginary lines. And similarly, negative charge have electric field of lines, but these, let me write it with same color. The negative charge have electric field of lines, but these electric field of lines are directed inward like this. They are directed inward toward the negative charge. So dear student, as a whole, the electric field of lines are around positive and negative charge. Basically, they represent overall an electric field. So whenever suppose that this is this first charge, suppose this is a charge 1 and this negative charge is a charge 2. Whenever this negative charge is brought near the electric field lines or electric field of a positive charge, then the negative charge will basically feel a force. And since you know that opposite charges attract each other, So the negative charge in electric field of a positive charge will feel a force of attraction. Similarly, dear student, the positive charge or the same charges repel each other. Suppose that we have two same positive charges. Let's say it is a Q1, this one is Q2. Electric field of lines are directed outward from Q1 like this, like this. Similarly, electric field of lines are directed outward from Q2 like this. So now dear student, whenever this Q2, suppose that this Q1 is at rest or it is static, and when this Q2 move toward the Q1 and it's the field of lines of Q2 reach to the field of line of Q1, then there will be a force exerted by Q1 on Q2, or there will be a force exerted by the field of Q1 charge on Q2. Since you know that both charges are same, this means that like charges will repel each other. So force of repulsion will be exerted by a Q1 charge on Q2. So, dear student, we can calculate the amount of force exerted by a Q1 on Q2 by a famous Coulomb equation, which is force is equal to 1/4 pi epsilon naught into Q1 Q2 divided by R square. This means that force is directly proportional to the magnitude of charges. So the strength of a field will depend on the amount of the charges. Amount of the charges or magnitude of charges basically tell us about the magnitude of the strength of electric field lines. So the stronger are the electric field of line, or the stronger is the electric field, stronger will be force exerted by a Q1 on Q2. Similarly, force of attraction or repulsion, here we are using two positive charge. So for this, force of repulsion will be inversely proportional to R square, which means that if the electric field of lines electric field of line from charge, electric field of line depend on the distance between the charges. So greater is the distance, the strength of force exerted by a Q1 on Q2 on Q2 will be less. And if r, or the distance between the 2 point charges, is closer, then the field will be then the force exerted will be great, or force of repulsion between two positive charge will be more. So basically, dear student, this force of repulsion due to a positive charge is basically depend on the field of a line around the positive charge. So field of line, the net amount of field of line, electric field line basically is overall field of lines around charges are basically known as electric field, whereas the strength of electric field line at a different point is basically known as electric field intensity. So now let us define electric field intensity. Student, electric field intensity is a strength of electric field. It is a strength of electric field. At any point in a space near a point charge, or we can say it is a force. Electric field intensity is basically force exerted by a point charge on a test charge. Or we can say electric field intensity is an amount of a force, amount or magnitude of a force, of a force per unit charge. So we can write electric field intensity in a form of equation. Electric field of intensity is equal to force per unit charge. The unit of electric field of intensity is Newton per Coulomb. Dear student, keep in mind that the unit of force F is equal to Newton, whereas unit of charge is equal to Coulomb. So the unit of force will become, unit of electric field of intensity will become Newton per Coulomb. So now, student, let us discuss how can we determine electric field of intensity at different point near a point charge. We can do this by converting the electric field intensity equation into electric field intensity equation with a distance r between a point charge. Suppose that we have two charges. One is plus q charge, and this charge we say it as it is a test charge, whereas there is another charge plus q charge, and we say that this q naught charge, we say it as a test charge. So now the distance between these two charges is r. Now let us calculate the electric field intensity exerted by a q naught charge or a test charge near the q naught charge near the q charge, or near a point charge which is q. How we can calculate electric field of intensity around the q charge felt by a q naught charge? Student, let us draw the electric field of lines around this q charge. The electric field of lines, you know that it is basically in positive charge. These electric field of lines are directed outward like this. We represent it by a dot. So these are that. So we can basically around, since you know that electric field of since you know that the positive charge have electric field of line around it, and they are spread it around the positive charge. So we can basically calculate electric field of intensity at different point around this positive charge. But how we can do it? Since you know that electric field intensity is equal to electric field intensity E is equal to force exerted by a test charge. Okay, so you know that according to Coulomb law, force is equal to 1 over 4 pi epsilon naught into Q, which is a point charge, into a Q naught, which is a test charge, divided by R square. So from this we can incorporate the equation number 2. Suppose this is equation number 2 into equation number 1. Then we can get electric field intensity is equal to 1 over 4 pi epsilon naught into Q1, Q into Q naught divided by R square into 1 over Q naught. So Q naught will cancel with Q naught. So we will get an equation for electric field intensity as 1 over 4 pi epsilon naught into Q divided by R square. So electric field intensity E become 1 over 4 pi epsilon naught into Q divided by R square. So from this equation, we basically can calculate the amount of electric field of intensity at different point near the point charge Q. So in case if we have a negative charge, so the electric field intensity around the negative charge can easily be determined just by using minus sign into a same equation 4 pi epsilon naught into Q divided by R square. So this is for whenever a point charge is negative charge. So for this we can use the equation for electric. For negative charge we can use this equation for electric field of intensity. So now this is all about the electric field and electric field of intensity. Basically, electric field is a region around a charge in which another charge feel a force which is exerted by a point charge. On a simple word, electric field is a region around a charge in which other charge feel a force. And electric field intensity is basically a strength of an electric field.